Welcome. Thank you for joining today's workshop. I appreciate the time that you're going to use today on this workshop over the next 3 hours. I think you'll find that it's going to be time well spent. And we'll come to all of the different points as we go along. So this is a technical workshop number 1, Migrating Workloads for the app dev community around containers and cloud native. So let's actually kick off. As I say, I welcome you not only to this Cloud Native Roadshow, but this is in fact our second season of the Cloud Native Roadshow, and it has some very interesting sort of spins where we've grown from the first workshop. 2 years ago, we were on the road. We were touring UK and Ireland in that case, and the plan was the following year we would travel out to mainland Europe and beyond, and of course our delightful COVID-19 hit and destroyed those plans overnight. So here we are again though. So this of course is a virtual workshop. It's a little different, and I certainly for one would look forward to the days when we can get back to the real workshops, because I know it's been a lot of fun and we get massive interaction from you as well. So, but we'll keep moving on because this must all move on anyway, because everything has a pace to it. So once again, this is in partnership with Red Hat, and I thank them very much for the efforts they put in the background, making everything work and providing us with all the help and support as ever. So I'd start by saying in the 2 years, and it probably points to why I've got this picture up, in the 2 years that have passed, we've conducted many OpenShift deployments, and that's thanks to OCP4 as that moved from OCP3. Really things were tremendously a great deal easier on that deployment. And so they've all gone very well. However, that's only the start of the journey. And we found that we were finding increasingly more time was spent on after the event, after the deployment, and therefore app dev. So what we thought is, well, in this series, whereas the last one was an ops track, if you might remember, and a dev track, and we went off to our different rooms in all these hotels around UK, Ireland, this time it's absolutely focused on app dev, because it's a little bit like the picture suggests in the top left. That's what we would like. That's utopia. We're setting the cloud native bird free to fly into the skies, into the cloud as it were, and everything is wonderful. The truth is, as many of you know, coming from either banking sector, healthcare, automotive, it's a little bit more like taming the dragon. And so the spin of the picture that I have in here. So what we hope to do, and a little bit like DevOps itself, this won't be overnight, but what we hope to do is over the period of this year, through these workshops, and also intertwined with some very interesting webinars that we're going to do, we hope that we can sort of open up this Pandora's box a little bit more to really allow true DevOps to be enabled in your business. So the agenda. So I'll chat a little bit about our company, Crossvale, and then I'll just touch on the light version of what we're really trying to achieve by this Cloud Native series, and then we'll dig into it. We'll hand over then to my two colleagues, the esteemed colleagues, or geeks, whatever you want to call themselves today, guys, that will have joined me today, Carlos and Marcos from Madrid and Barcelona. And they will then take you through the actual workshop where you can get your hands dirty. And if you're watching this post, if you've gone on the on-demand version of it, then of course you won't be able to avail of that. But what you can do is fill in the form on the website, reach out to us, and we can actually set this up for you. And so you can actually do a workshop with us post. Okay, so obviously this is live right now. A little bit of housekeeping. You're muted. That's just so that there are noises going left, right, and center, and dogs barking in the background, as you're probably all at home and things like this. It's been recorded, and that's of course for your benefit, so that we can send that, make it available, send it out to your company, and you can circulate that through your company as well at will, no problem whatsoever. Also, there are sort of 3 ways of connecting with us during this particular workshop, and that's Q&A, chat, and raise a hand. Q&A, you can use whichever you like. I'm not going to get hung up about it, but Q&A just put in some general questions, maybe just about cloud native. What do you think about Quarkus? What do you think about the direction Red Hat are going? Any questions you like. We'd be really interested to get those questions. May not answer them all today. We may just take those questions. We may come back to you on a one-to-one later. So, don't feel that it's out there for everyone to read. We can then take some of the questions and may just put them back into the rest of the group. Chat. If you want to just chat away, let's say you have a little trouble logging on the URL, which Marcos is going to put into the chat window in a moment. If you have a problem, chat it in there and we can get straight in there and help you immediately. And on that point, don't worry about whether you do or don't have any problems or challenges throughout the next 3 hours. The workshop will remain open for the next 24 hours. And again, thanks to Red Hat for doing that and allowing that to be open for that long. So that's very much appreciated. So firstly, I will keep it brief. Who is Crossvale? I think it really starts, everyone talks about digital transformation. And I think it's well used by this stage. The meaning's nearly getting diluted. It's still as important as ever. But what we like to talk about is modernization and creating frameworks around your infrastructure processes and your application development processes that ultimately drive results in your business. Just at the bottom there where it says the most important thing, we're hybrid heavy, and I'm going to come to that point. So we really work with you through 3 major cornerstones from our business to your business. It's automation, it's hybrid cloud, and it's SDLC, software development lifecycle. All of those 3 all have the same pinnacle. It's getting to the speed that your business demands and needs to keep up with competitors, people who haven't even come into the market yet, that you already feel are biting at the heels. And it's to keep you either one step ahead or be ahead. And that's what these cornerstones are really all about. And another webinar, and if you look into our events page, we actually have some webinars on these in particular. That's not the purpose of the today, just to say that these are our pillars. Also, we can have our little proud moment, and if you don't mind, I'll take that just for 30 seconds. Once again, we are a partner of the year for Red Hat as both a premier and advanced business partner with Red Hat. In 2021, we have done it again, and thanks to the whole team across Crossvale to be able to do this. But this year, whereas in the past it's been our application platform built on OpenShift, it's been our leading edge processes built on OpenStack and OpenShift, and this year it's on our customer solutions, which is really all about the higher layers of the middleware, business process automation, things like this, BPM, and tools like this. And that was particularly in the banking sector where we won that award for. So I'm delighted for the greater Crossvale team that was able to deliver that, and continues, in fact, to today to continue to deliver that to that client. So that's 4 years running. And 4 years of doing what? 4 years of going from delivering your day zero, not our day zero, we've been around for 20 years, but getting you from that day zero of a product and taking you through to day one where the product is actually delivering a true solution for you. And then finally day 2, where more so the operations team, not particularly this group on here today, but where they say, okay, can you just take care of this? Can you maintain this so that we can grow? Because really, we need you to be one step ahead for us. And that's the type of business that we offer our partners and our clients, is really going everywhere, whether it's learning, whether it's designing, or whether it's managing. Crossvale are on that same journey with you as you learn. So where are we? How are we there? When are we there? Well, we deliver, I like to say on site, but for 2020, not quite on site, but we are all around EMEA. It's the 4 corners of EMEA. I'm based out of sunny West Cork, but we do work, as in this week, out in Qatar. We're also with our other guys down in Cape Town, and we have offices in UK, Spain, and the US. So reach out to us no matter where you are. I know we've got guys coming in from India, here at Johannesburg, we've got someone coming in on. So no matter where you are, reach out to us. And yes, we will be on site again. And actually, in fact, we are starting to go back out on site already. As those planes are spinning up, we can get out there as well with all the correct procedures in place and processes that we operate within the COVID regulations. So again, I mentioned it just earlier. I mentioned the events page. Do go to the events page because we're only touching on some subjects today, but we do have on-demand webinars and some of the workshops. Now, the workshops aren't that useful on demand. It's more to know that we do those workshops, and you could say, hey, I would be interested in one of those workshops. So either look out for ones that are coming up, or go on some of the webinars that have already gone on, such as, like I've listed here in a moment, is the OpenShift one. We've got some great webinars on it. RHEL. Are you on RHEL 6? Are you on RHEL 5? Because you simply have to be, because that happens to be where your application 12 years ago was built and you just don't know how to move it. We can. We can help you migrate it, or we can give you the advice around how to migrate that, or possibly even refactor or rebuild that application. And also Ansible, the truth and the world around automation itself. We've got some great webinars on that. And really, when you talk about OpenShift, you can't help but talk about Ansible as well. They are absolutely intrinsically connected to each other. And in fact, we use playbooks constantly when we're doing our OpenShift deployments. We wouldn't live without it. And so you imagine, for example, in the world of ITSM, and you're requiring to build and spin up new clusters, new environments as your customers. If you're in IT, your customers are requesting this, then the Ansible is the way forward for that. So these things are working absolutely hand in glove together. So please go to our events page. And not only our events page, go to the Red Hat events page. We're there too. But go to there because they've got some great they work with tremendous partners. We're one of those, but there's an ecosystem of partners. Go and see what else is going on and learn as much as you can, and come back and ask us any questions. We'd love to hear questions from you and get the chance to talk to you. That's what we're all here for. So today, back to what we're doing. So that was it. That's all I'm going to talk about with Crossvale. You won't hear from me again shortly. It'll be handing over to Marcus. But the virtual workshop series, hopefully we can turn it into real live ones as the year progresses. But for now, let's call it virtual. We're doing a series. They are totally connected to each other. Today, 5th of May, Migrating Workloads. Again, if you're coming in on demand, just so you know, this is on the 5th of May. On the 30th of June, we will be doing pipelines, CI/CD, Tecton, and I'll talk about that in a second, as opposed to Jenkins. Again, Red Hat, OpenShift, it's all moving on, it's all going native, and I'll say what I mean. Service mesh. We're going to be talking about MSA, microservice architecture. Service mesh is intrinsic to that, and everything. It's about the connectivity between your containers. So we will be covering that in the third quarter, I suppose, or 15th of September. We'll let you all go off on your potential holidays in your back gardens, and 15th September we'll come back and do that. Then as we push on later in the year, we're going to go to serverless. This has been something that's been very much out there, feathering from Red Hat, but it's very much now becoming full steam ahead, and we'll talk about that as we get to the 27th of October. We'll touch on it a little bit today, but we'll get into more meat and bones on the 27th. However, the last one, 05, anytime, for any length of time, we do it every day with our teams, we have customized, bespoke workshops. We have many off-the-shelf workshops. So if you just say, what have you got? We've got them. Well, do you want an Ansible workshop? Do you want an Ansible mixed in with a bit of OpenStack so you really get to understand how to deploy automatically your private clouds? We've got that. So come and talk to us about what you want. Look at the Red Hat. Tell us where you are on the journey of the whole modernization, and we will have a workshop that will suit you, your team, and your budget. We will have a workshop for you. So do come and talk to us about that. But today, migrating workloads. What we're going to touch on as we kick off is the migration toolkit, MTA, as it's aptly called. Then what we're going to do is actually look at a JBoss EAP and start a migration. And then we're going to get that good old monolith and do a sort of phase one of breaking the monolith. And this will introduce you to one of the runtimes that Red Hat has brought into the OpenShift ecosystem, which is Quarkus. So we'll touch on Quarkus. We're actually going to run a webinar just on Quarkus later in the year, so do come back and join us for that. It'll be on our events page. Then, if time allows, we're going to get in a little bit, get the hands dirty, and actually drive into the monolith a little bit more. But on that point of if time allows, as I said right at the beginning, we're going to leave this open for 24 hours. So don't worry where you are, where you get to. If you only get to part one and you're absolutely up to here, or you've had to dash and get into a meeting, not to worry. Come back afterwards, have your dinner or whatever, and carry on, and you can pick up where you left off, finish it off, and we can track, and you can ping us some questions. My email will be there, okay, later on. So that's what we're going to try and achieve, and say we'll push on, and just for a few minutes, if you'd bear with me, all I'd like to do now is, that's Crossvale, that's the workshops that we're doing. Let me now just very light touch set the scene. And the scene is 3 simple areas. It's all about process, architecture, and the platform. These are the 3 pillars, if you like, as I spoke about with Crossvale pillars. These are the 3 pillars of the journey. If you get your process right, and you get the right architecture in place, microservices being a possible route for that with the API branch outs. And all of this is not only in containers, which it has been for years, but the orchestration of those containers, i.e. the platform, in this case OpenShift. If you get these 3 right together, then you are better paced to get that journey to completion. So that's really what it is. So I don't think any of us, even on this call today, certainly judging by some of the emails, i.e. the companies that you belong to, no one needs to be told that things are changing. We only have to look at the companies out there, the Netflix, the Ubers, and companies like this of the world. It's the pace at which they're changing. And you've got to keep up with that pace of change. Because you put it simply, you will either be replaced or simply fall behind, and that will put a pressure on your EBITDA and all of these types of elements that your business cares about. So your process needs to change. Your architecture needs to change. And if you haven't already done so, you need to be on OpenShift so that the platform is ready and built to go forward. So welcome to DevOps. Some people actually call it DevSecOps because ultimately what you need, you're not in just a dev world. You're not just building a dev environment. You're building a production environment. So what you need is a security blanket that surrounds DevOps. And that's my version of the DevSecOps. And that's really what it's really all about. And we spoke about this last year and the year before, and we're not going to go through the whole digital Darwinism again. But what we are going to do is say something that's really important, just a couple of points. DevOps starts with people, not product. So you can buy all of the OpenShift you like, and we would all love that you buy lots of OpenShift and everything that goes with it. But if the people are not behind it in the business, you are more likely to fail. And we've experienced that. So we're talking from the horse's mouth that we've seen this, and the effort we put into things like this workshop is for this reason, is to get people to reorg themselves. And this is not only in your group, in the app dev, not only is it in operations, but the business which umbrellas you must also set the ultimate goals to say, this is where we need to be. And you've got to say, and this is how we get there. You need on demand. You need to be able to self-service provision your environments, not submit a ticket and wait for someone to write an email back in 2 weeks saying, I'll get to it next week. Therefore, it needs to be automated. Your job then comes into CI/CD, which we'll be doing later on this quarter in continuous delivery. Then you look at advanced deployment, your blue-greens, your ABs, techniques like this, which allow you to test and check, is this working? What was the reception like? Okay, let's load here instead, and you try techniques like this. And then and only then do you actually even look at microservices. Not today, even though we're going to talk about it. Even then, you may only look at what we would refer to as the fast monolith, which is something we're talking about in a moment. So it's taking that monolith and adjusting it ready for the process known as lift and shift. So the key to this is, as is shown on the graph here, DevOps is sequential. It's certainly not something that happens overnight, and we certainly don't profess for it to happen overnight. But what we do profess, and Red Hat have done a great job of doing this, is ensuring that the dev group are really well looked after. I spoke earlier that when we went from OCP 3 to 4, the world got just fantastic. I mean, it really did. So in terms of ops, you're really through IPI installations. It really started, I don't used to like the word easy, but you could see the simplicity coming, and that's what was happening. Well, now what's happening is they're bringing that same simplicity or building out a platform for dev people. So of course, on the left, you got OpenShift. We all get that. It's OpenShift. That's the platform of choice. Up above that, the next platform up there is the middleware stack that really is all around the services, things like the service mesh that we talked about. And middleware itself is an enormous portfolio that, in fact, we at Crossvale have been heavily involved with for double-digit years now. And it's the bones. I mentioned BPM and things like this, process management and automation. That's the bones of where it really all starts to happen. But it's no good if dev are still pulled back down in the weeds and they can't themselves get tools to enable their productivity in that Kubernetes environment. So really, it's the Red Hat Code Ready, as they've named it, the Code Ready group. That's really where you really start feeling in the app dev world that you're being looked after and these tools are coming to you. So OpenShift. Firstly, this is not a 101 OpenShift today. I can send you either to our events portal that I mentioned earlier, or the Red Hat On Demand. There are just some fantastic 101s on OpenShift. Go to openshift.com. Go to any of these places. There's just too many out there just to sit down, you know what, and in 60 minutes, take a brain dump of everything that's going on up to today. Make sure you do an OpenShift 4. There's no point learning about what's going on in OpenShift 3. So get one that's up to date and do a 101 on OpenShift, and to really get the most. And don't just do your world of app dev. Go look at what operations are involved with as well, okay? It's really important. That's the word DevOps. What I just want to do is pick out just a couple of the key elements that are going to be touched on in a moment by Marcos and Carlos and other guys. And also, as the series unfolds, we're going to be touching on these. So immediately, even when you see this graphic there on the left-hand side, OpenShift is far more than a platform. A platform is, you think of things like a train station where just something comes in and then goes out again the other side and it's never to be seen again. It doesn't do it justice. What we're really looking at, now this is only from a Crossvale perspective, is that it's more of an automated ecosystem. And that is what you see here today. You see up at the top left, it's the ecosystem for operations. And then over on the right is the world we are in today, here all of us today, and that's the developer services. But all of this is sat on top of automated operations, the things that you just don't see, being frank, care. You just want it to happen. It's nearly like you live in a bubble or a container, and you just need to get on inside that, knowing it's going to do what you've been told so many times it's going to do. And it's going to do it wherever. You see there, physical, bare metal, the virtual environment, some VMs that you're spinning up on a bare metal. Is it a private? Is it OpenStack? Is it a multi-hybrid OpenStack across different regions of the globe? Or is it public? Are we going out bursting to Azure? Are we bursting out to the Amazon AWS? Are you taking a mix of these? And it's the mix, frankly, of all of those four that is the real norm today. And we're seeing this mix more and more. There was a little spurt where everyone was going out to public only. And then as time went along, they started thinking, okay, we need to mix this up more and more. What OpenShift allows you is build it once, run it anywhere. It does not matter. You don't have to care about it. There are things you need to care about, but you can do that inside the container. So let's get into that a little bit. Let's live in our world here today. We talk about ecosystem of what OpenShift is. Well, what it is for the developer in the app dev community is it's all about almost the life cycle management. So from code all the way around, follow it yourselves, to review, it's that life cycle. And it is sitting on top, working through data and services. Are you Ceph? What type of storage do you have? What networking is actually going on? What communications are required between each of these pods? What type of service mesh do we have working here? If we're talking to another multi-cloud, is there latency that's going on here? How do we measure that? What logs and metrics do we have built in to warn us, to do prescriptive, preventative maintenance on our applications? This is true developer productivity, which ultimately accelerates you. And that's the bare bones of what we're doing. So not today, but for the next one, and for those, again, who are on demand, it could even be it's tomorrow. But for the next one, we'll focus on what is referred to as these next-gen applications, which ultimately are looking at breaking down and working more on the cloud-native runtimes. So building it more in runtime environments that can look at service mesh, so microservice architecture with service mesh communications in between. With serverless, where we're actually doing scale to zero function as a service. So they're the sort of elements that we're going to be talking about next. So they're the pieces that we need to start introducing. And as I say, we'll actually dedicate a whole workshop just to that slide that we showed. So it's fine to say, we'll take OpenShift. We'll have, 18 subscriptions of that, 4 nodes across each of our environments. But moving to the technology isn't enough. You have to actually not only change the technology from a VM to a container, that sort of, step process, but also you have to change the way in which we build. And so we know that we build in an agile, an incremental, a small iterative process. The building block to that incremental small process is the container. It's where your workload or loads, you can have multiple workloads in a container, can reside. Move that on, let's start scaling a bit. There's no point having one container with one application because, well, if that was the case, why did you do it in the first place? You may as well have just stayed on bare metal and left your application where it was. What we want to do is scale. What we want to be able to do is en masse move to multiple environments. That's when doing containers is actually really hard. And anyone that's done it, and I'm sure you possibly have already done it and can still do it today, you know that really what it is if you bring a platform, that's when you start making your life easy. So the platform that it's on, that's what actually matters. And that is OpenShift. What you, though, care about is, let's go back to that unit, is you care about your code, how it integrates to other pods, other units outside of your unit. What runtime is that on? And is that on the OS that I need? That's what you need to know is happening before you even think about it. It has to be automated. That's what OpenShift is. It puts everything in that cell that's needed. No different to the body that I'm in today, and each cell has exactly the right composition of what's needed. So when I put in the code that's needed in that cell, everything else is there already. That's exactly what not the container is doing, but what OpenShift is doing. It's the orchestration of these cell units. And that's what is so important. So it's not just about a platform that sits all these containers on it. Does the platform orchestrate the actual bare units? And that's OpenShift. Then we talked about microservices. So if it's microservices, it's highly unlikely, even though you could do lift and shift, it's highly unlikely you've just got one application in one container sitting on one platform on one unit. What you've got is many of them talking to each other. So the focus now turns to the bit in between, the space in between the space, as someone once said. How exposed are you? Do you want that level of exposure? What control is there on the exposure? Is there latency between the exposures? Things like this Can I make my microservice architecture work harder for the money and therefore for the business? And of course, the answer is yes to these things. This is exactly, again, what OpenShift does so well. So finally, before I hand over, and I know you've had enough and you want to just get your hands dirty now, but just to be aware of this now, because building and deploying the OpenShift platform with containers waiting to be filled with the latest cool apps, it's only the start. For app dev, OpenShift and Red Hat, what they've done is provided smart dev tools that really allow you to connect. It allows all of the app dev teams to connect. In other words, they're kind of singing off the same hymn sheet. I know you can all go off and do it your own way. The whole point of DevOps is to sing it as a community, to follow a track which is working and all be contributing to that one. And that's what the Red Hat developer tools are. Now, today, we're going to be using the very first one across there from the Code-Ready family, which is Workspaces. If you've joined us before, you'll have known it. We'll have just called it Eclipse Chi. Now it's the supported Eclipse Chi. So that's what we're going to be using today. We're going to go into that. But also, it provides things like a containers, which is a local install of an OpenShift 4. And that's really, really handy. So useful, and so many people use that. Then you've got the fuller version of Workspaces called Studio. And then we have the Builder, which is all of the tools required for building onto RHEL. And then finally, Toolchain. And Toolchain is something, again, that's been around already, but now it's fully supported in the OpenShift family. So we're going to be coming to this. So just in case, it's not going to shock you, or if you've never used it before, this is what it looks like, probably environments you've seen before. And you've probably used ones like this before, but again, this is now supported, standardized, and all of your teams using the same thing. That's got to be a great asset. Standardization promotes DevOps. So it's that family of it's coming together. Also, and again, we won't be doing this today, but it'll be in a few weeks' time, we're going to be talking about Tekton. And this is now the Tekton CI/CD pipeline. You joined us last year, we were talking Jenkins, right? And things like this. And you may know other pipelines, but Tekton is built for native Kubernetes. And as you probably would recall or can go look up, Jenkins never was. Jenkins was built before Kube existed, so it wasn't built for Kube in the first place. What's great about Tekton, and now supported in the Red Hat OpenShift family, is that it's built for Kubernetes. So it's going to be streamlined, and the core thing being it's serverless, but that streamliness means it's so effective at doing those pipelines. It's very similar to how we used to see Jenkins run. You remember when it starts to build, deploy, check, health check, go back. It's exactly the same like that, but instead it's built on the Tekton project. So welcome to that in a few weeks' time. Finally, the developer console, again, just bringing the family all together, linking services, linking projects. It just brings it all together so people feel that, again, they're going down the same pathway. So that is it from me. Don't have to hear from me again, thank God, you say. So what I'm going to do now is I'll stop this screen share, and I'm going to hand over to Marcos, who will start up his. So let me end that show there. Let me end my screen share. I'll just stop that share. Marcus, let me hand over to you if you want to pop up your screen share. And also, would you do the favor, Marcus, and would you put in the URL so everyone can just get going on setting up their own logins and things like this?
Sure. Well, let me grab the URL. So I'm going to send to the chat the URL you can use to register in the environment, and then we can going to share my screen as well. And the moment you register in your URL, you should be able to see a screen like the one I'm having here at the moment, in which we have links to the modules that we are going to do in this workshop series. Today, we are going to start in the module 1, which is optimizing existing applications. Please let me know in the chat if you find any problem with the register in the environment. So first of all, mind that the username that is going to be assigned to you is important, because that username, when the applications are deployed in OpenShift, is going to be important in the endpoints that we are going to use to call one service from another. This workshop, any code that you may see, you can just click and copy, and you don't need to go line by line or write everything that is here. There are some Java code or some shell commands that we may need to use in the workshop. So to summarize the environment that we are using, as Mike said, we are using mainly in this workshop module number 1, we're using OpenShift and code-ready workspaces, which is Eclipse G in OpenShift, and we will be using also the application migration toolkit that we will see in a minute. Is there any problem loading the register into the workshop?
And we just and thanks, Owen. And so we've also just put in the password as well. So I just put the URL, get a username, Labs Infra. I just put that URL in as well, just to the attendees there, Marcos, just so the attendees were seeing it. And also we've got the password there. So you guys can put that in. Just put your hand up. Just click on raise hand if that's not happening. Otherwise, you should get your user IDs.
That is great. Thank you, Mike. Okay. So first of all, while you are logging in, I would like to go over what we are going to do today. So as an overview, we are going to take a legacy WebLogic monolithic application, and we are going to transform it to run it into JBoss in OpenShift. That is going to be the first lab that we're going to do today. Remove anything that is WebLogic specific and have it running in OpenShift. But that is not breaking the monolith. We will need to implement some services that the monolith is exposing to a frontend, and we will move that to microservices. And that is what we're going to do in the lab number 2 with Quarkus, and in lab number 3, with Spring Boot. So first of all, when you are logging, you will need to check that you have access to the development environment. The development environment is the Eclipse G that we are going to use. Just click this link, and it is going to ask for a username and a password, which is the username is the one that you have assigned. In the case is user2, and the password is Red Hat 1, which is the default password here. And exclamation sign, so I can log in. So when you are inside the workspace, you can click here and open this action button on the right corner. And in a minute, we should see the Eclipse workspace running. Okay. I already have the Eclipse running. We have multiple functions here, like explore the file system, search for a file or something. We have a source control plugin, and also the migration application tool plugin that is available for this code-ready workspace. So first of all, what we will need to do is to download the code from this workshop. That URL should be here. So we only need to copy this and just go over and clone. Project is okay. Okay, so I have downloaded the code from the workshop. I will give you a minute to see if you can. Okay. Give me a moment. I can search the URL. The URL is okay. Okay, so one important thing to check before we start with the code is that it's set in the workshop to check that the branch is OCP 4.5. In order to do so, we can open a terminal. So click this cube icon on the right and open here new terminal. So right now I am the projects. So I have the Git repository cloned here. I need to go in and I can just go and check out OCP 4.5 branch. And I am already on that branch. So please check that this is the branch that you have, because if not, we may run into some problems down the road. Okay, so at this moment we have the code ready workspace up and running. We have cloned the code that we are going to use, and we have validated that the branch is the branch that we need to the OpenShift 4.5 version. Now what we are going to do is to use the application migration tool plugin to see if the application has any problem before doing the migration. So in order to do that, we need to click this button here, and we will need to, I'm going to close this window here, and we will need to add a new NTA configuration. In order to configure this, first of all, the input is going to be, we will open the file explorer, the monolith folder inside the repository that we have cloned. The target, we are going to see EAP7. And the source, where is the source? We have to click that we have specified the source. And in this particular case, it's going to be WebLogic. We click add, not in add. Okay, so we need to right click NTA configuration and click run. Now in the right corner, you are going to see a pop-up that is saying preparation analysis configuration and some output in the code ready workspace. We will give it a minute to run. Okay, analysis is finalizing right now. So the good thing about this plugin is that it is going to So a report. So here, analysis complete. You can click Open Report in the down right corner. Click Open Report, and this is going to be a list of applications that we have analyzed. In our case, there is only one, which is Monolith. And these are all the issues that the plugin has found. We can take a look at the list before going into. So for example, there is a WebLogic proprietary logger that we will need to change because we are not going to be running in WebLogic, and some other WebLogic specific configuration that we will need to modify in order to be able to run this application in OpenShift. These errors, we can see it on the code here. We go to the to the NTA view. We can select a Java class. In this case, we are going to check the startup listener that we have here, and we know that there are 6 hints that are going to tell us that something is wrong with this code and that we should change it in order to run it on OpenShift. It is possible to view the details of an issue. In this case, in this class, there are 6 hints. We can right-click any of them and click View Details, and it is going to give us some description about what is not okay in this application. In this case, it's the application lifecycle event that must be replaced with a standard Java EE servlet context event, and that is something that we will need to do in order to modify the application code to be able to run it in OpenShift. So we can go to the code. You can go and check the modifications that we need to do that are particularly in this Java class is the one that we are going to be modifying our class. So basically this logger, not the logger, sorry, the application lifecycle event and the application lifecycle listener are WebLogic specific classes that we will no longer use, and we will change that but standard single dot and startup annotations with a post construct and a pre-destroy instead of extending this WebLogic class. So we will need to delete this extension because it's WebLogic specific. These imports are not needed anymore. This class is going to be declared as a singleton. Let's wait for the autocomplete to come on. No suggestions. Give it a minute. It's going to be running on the startup, and instead of having this post start pre-stop methods that are extending WebLogic classes, we can just annotate this as post construct and pre-destroy. So I can save this. Okay, so this is not going to work. Of course, I need to import all those classes that I need. So I'm going to click here and paste the code that we need. So I imported all the classes and all these annotations that we are going to use now. So what we have done right now is an application that was coded for WebLogic that was working okay. We have removed all the WebLogic specific code, and we have changed it into a more Java standard construction. So now we're going to check that the build is okay. In order to do that, we need to do a Maven build. So in the right menu, click New Terminal. And we need to go to the folder, which is Cloud Native Workshop Labs / monolith. And we just do a Maven clean package here. Okay, so the build is okay. So all the code that we have changed is correct. Now we will need to change some of the other problems that we found. Let me go. I will change to the other view to make the modifications. So the modifications that we're going to do right now we have tested the build already, are the logger issues. Please let me know in any moment if you are lost or you have any problems while doing the workshop, and we can fix it together. We will need to change these logger problems that we have into the order service NDB. The problem is, as well as it was before, that we have if you check the logger here, is a WebLogic specific logger. This logger is a non-catalog logger instance that is being used in the code below by the order service NDB. Now, in order to change this logging, what we are going to use is a Java util login.logger, which is a standard logger that is going to be able to run in OpenShift. In order to change this, we need to go to this code and just copy and paste here. The only thing that has really changed is this logger here in line 28. Now it's no longer a WebLogic class, it's a Java util package class, so we are okay. And just in case as we modify anything, we will need to go and test the build again. So we do a Maven package build. Okay, it is successful. So the changes that we have done right now are correct. And we will need to go and change the final modifications that we need to do in order to remove all the problems that the migration application tool has detected. So one thing that we need to change is that in this particular case, there is a use of Java message service. In this case, a message is sent to a topic, and then there are some WebLogic specific configuration that we will need to replace by some JBoss configuration. In this case, some of the resources that we will need to remove should be not here, sorry, should be here. This, for example, is a configuration of a transaction timeout in seconds. This is a WebLogic specific configuration. This will need to be removed, and we will need to delete this file that is specified in the workshop. This file will no longer be used because in the workshop we are not running WebLogic anymore. So this configuration is not needed. Let me close all the resources that I have opened. So under monolith, in source, web app, webinf, there is a file which is called weblogic-eav-jar.xml. This is not longer needed, so we will need to delete that. And we will need to delete also the WebLogic folder, which is under Java. There is a WebLogic folder. All of this is WebLogic specific. We don't need it. We are not running on WebLogic anymore. And finally, we will need to modify the service itself. The service is under the service package. It's called inventory notification NDV. This will have to be changed by this code that we have seen here. So mind that what we have changed, we have not changed anything on how the application is working. For example, the timeout that I shown before is configured in this application here. It's a transaction timeout of 30 seconds. So this JMS component is going to behave the same way as this was working before, but instead of running on WebLogic, in this case, it's going to be running in JBoss. Finally, we will we'll need to remove some dependencies in our POM. Okay. So this dependency here, we don't need it anymore. So we can go away and delete it. And we need to test the build as always that we change something. Okay, it's okay. Now we are going to run again the analysis of the MTA tool. Have someone find a problem while removing this WebLogic code? If someone has found a problem, please let me know. So analysis is in progress at the moment. So we have not done yet any OpenShift specific configuration. We are migrating from a WebLogic to a JBoss, and then we are going to run that JBoss in OpenShift. We are going to check the report, and if I have done everything well, there should be no errors. Okay, so we go and we open the report, and we have 0 story points, so we don't have any problem here, which is great. So now what we need to do is to prepare the application to be deployed in OpenShift. In order to do that, there is a Maven plugin that is that is here, a Maven profile, sorry, that has a Maven plugin on it. We will need to copy that profile and go to our POM file, which is opened already. And we can add the OpenShift profile here. Okay, so this is the OpenShift profile that we will need to use in order to change the build of the application to be able to run it in OpenShift. So before we run the build with the OpenShift plugin, we can go and enter the OpenShift console just to check that everything is there. The credentials to log in this OpenShift console are the same that you used to log in into the code-ready workspace. So in my case, it's user2 and Red Hat. Okay. So I can see that there are some OpenShift projects already created for me. And we will need to check that the project that is named CoolStore Dev is created. It's not created, so we will need to create that OpenShift project. So in order to create the project, we click the Create Project button. We give it a name, and we will give also a display name. And we click Create. Okay, so we already have this this project up and running on OpenShift. I'm going to change to the developer view, and we will need to deploy the application that we have written. So in order to do that, I'm going to here in the topology section, we click from catalog. We will need to uncheck this operator based type, so we can see all the options. I will filter by CoolStore. Okay, CoolStore monolith using binary build. This is important, not the pipeline build. We're on the binary build today. We go and select this and create instantiating template. User ID, in my case, user2. Sorry, user2. In your case, will be the user that has been assigned to you, and we go and click create. So this is going to create some resources in OpenShift. Okay, so this is how the application would be deployed by using the web console, but it can be deployed also like using the CLI. We will need to log into OpenShift in the code-ready workspace, which is a button that is here. We double click that, and it's going to ask for username, user2, and password, Red Hat. Okay, so I can see all the projects that I have here, which are the same that I have accessed in this console, is not different. And I'm going to okay, it is having some problems. I'm going to refresh the page. If the code-ready workspace is scanned, just refresh the page, and you can go back, and it will work better. So in this case, user2 again, and the password is going to be Red Hat. Okay, login successful. So I think that I need to open a new terminal. Let's see if I can access. Okay, that was the problem. I was using the wrong terminal. So now we can go and change the project to what was the name? User could store dev. OC project. Okay, now I am using the project that I have created before. Before starting with it, we will need to label the applications and annotate everything. So we will copy all these labels and annotations, which are metadata that are assigned to the OpenShift resources. And there you go, it's already there. And now the application is not already deployed because we will need to do it using a binary build. A binary build is a build in OpenShift that allows you to specify the input from outside the build. And in this case, the input of the build is going to be the Maven artifact that we are building with our OpenShift profile that we have created here. So we just copy that command and execute it. Okay, build is success. So since the build is success, we will have a war file built, not in here, into the monolith module. So we can, well, we have changed it. So the file should be, okay, I'm doing it wrong. We have changed it with the Maven plugin. So it is not here. The war is on deployments. Okay, this is the war that we will use to deploy to OpenShift. So in order to deploy this war file, we can go back to the workshop and start the binary build. So this binary build is an object in OpenShift, as I said, that is going to take as an input the war that we just built, the war file that was built by the Maven build. So now it's uploading the file as a binary input for the build, and uploading finished, and the build is started. So going back to the OpenShift console, we can see the build configuration here. And if we click in the builds tab, we can see that one of them is run, which is the one that we started. So the build is running, as we can see here. It is also possible to check here. If we do OC get builds, we can see the same information as in the console. So everything that we can do in the console, we will be able to do it on the command line interface. And now the build is complete. So we go back to the topology tab and go to this Red Hat JBoss. This light blue means that the application is not yet ready. And if you click that, you can see that the container is still being created. It is running. So we go to the logs. We can see the logs here. but we are not worried about the logs. We want to see if the application is ready there. It's not ready. The moment that this blue becomes dark blue, as it is on this database component that was deployed in the template that we deployed before using the catalog, like right now, then the application is ready. So we can refresh the page. And we can see the web application up and running in OpenShift. If someone is unable or someone has a problem reaching this point, please let me know in the chat. This point is important to have something running in OpenShift, although it's not strictly necessary to continue with the workshop. So in this first laboratory, we have taken a legacy application that was running on WebLogic. We have modified the code and execute a JBoss in OpenShift with the same application that we had running on WebLogic before. Right now, the problem is that the monolith has not been broken because it's the same application that we were running on WebLogic, basically. In order to use all the resources and all the advantages from OpenShift, we're going to need to go and break the monolith. So in this lab, as you can see in this diagram here, this is the cool store project that we have deployed, a monolith and a database, which is what you can see here, the JBoss and a Postgres database. And what we're going to write right now is an inventory microservice built with Quarkus that we are going to deploy with a database as well. And in the future, we will add some more services so we can move the UI from consuming the monolith to consume our microservice architecture. So first of all, we will need to go back to the code-ready workspace. You don't need to clone anything else. You have the inventory service here under the inventory folder. And we are going, before going into the code itself, we are going to check the dependencies. So we have the Quarkus dependency, which is important, and Quarkus REST dependency. What we're going to build basically is explained in this image here. Is basically a REST endpoint that is going to communicate with an inventory database using Panache, which is an ORM for Quarkus. So first of all, we will need to add some Quarkus extensions, this one that you see here. So Quarkus is a framework that needs an extension in order to run something. So in this case, if we want to run Panache, we will need to add the extension Hibernate ORM Panache. If we go back to the code-ready workspace, I'm going to go clear the screen and paste that command and run it. Okay, we see 3 checks here, like extension has been added. That means that these dependencies have been added to the POM. So instead of using a dependency, for example, H2 here, which is added, that we will use it. Instead of adding the normal H2 database dependency, the Quarkus extensions have to be used in this case. Okay, so first of all, what we will need to do, we already have the application which is dependencies created. We will need to go back here and create an entity. This entity is a Panache entity, which is using a standard annotation, but extending Panache entity. So we go to the Kubernetes workspace and we will try to okay, we will need to add the inventory entity file. So we go here, new file, inventory entity.java, and we paste this code. Oh, I did a mistake. This is completely incorrect. It's not called entity. It's this file here. Okay, sorry for that. So this is the entity that we are going to use to communicate with our database. It's the same concept as an entity in other persistent frameworks. Okay, so now we will need to create the RESTful endpoint, which is inventory resource. This Java class is empty. We will need to go here, and we are going to check this code first. So everything is Java RS annotations. We are going to expose an endpoint on /services/inventory. And if we don't specify anything, we are going to get everything that is on the entity or on the database. And we can also specify a path to the item ID, and that will return only that particular entity. So we go back to the, going to close this, to the inventory resource and paste the code. So we have services inventory and annotations that we are going to produce and consume JSON objects. Okay, so what we need right now is some data. In order to get some data, we need to add things to this SQL file here. SQL file content should be in the workshop. This is not something that we may want to do in production, but for this workshop is okay. We are going to insert data into the inventory database with these values. And we will need also to configure properties in order to connect to the database. In the application.properties file, we can go and paste these dependencies. We can go to the, where was it? Here, and paste this command. This, it starts with def because that is the environment identifier. So we will run it on dev mode first. And after we check that everything works correctly, we will add the production configuration that we need. Okay, so right now we will need to run the Quarkus application. That can be done with the Maven Quarkus plugin. In dev mode, which is what you can see on this command here. So in the workspace, we use the Maven command, and Quarkus will be running. We can go here, click yes. Okay. Okay. So now we have a Quarkus application, the Quarkus application that we have written running, and we will need to check that it is running. So I'm going to go to another terminal, and I'm going to do a curl into localhost 8080 /services/inventory, and we can see that the service is up and running here. Okay, so the application is running. I'm going to stop this. You can see that the port that is listening here. So the application is already running and is able to return the data that we have imported in this SQL file. So right now we are going to add a health group to the application. Well, we already have one, but I just stop it. In a moment, I'm going back to the Maven plugin and I can go here. I will start the Quarkus again. We already have one health check, but we are going to change it. Okay, it's not yet ready. It's ready. No, it's ready. This one, this one. Now it's ready. The application status is okay. We can go and check the health check by opening a terminal. And I'm going to is not opening. New terminal. Okay, I'm going to refresh the code ready workspace. Does anyone have a problem until now? We have a Quarkus application running locally. We will need to go ahead and check the health. We are going to check or to validate that the health check is running at the moment. So I'm going to run the Quarkus application again. And I'm going to open a terminal. Okay, I'm going to dismiss. You can open the Quarkus application in a different browser tab like this one if you don't want to use the curl command. So now I am going to execute a curl command just to validate that we already have a health check, and then we are going to add a custom health check. So I'm going to go to localhost 8080 and I'm going to choose q/health. And what I'm doing wrong, maybe I need application JSON. Okay, so I did this wrong. This is content type, it's not nothing. Okay, so there is a health check that is running and it's telling us that database connections are correct. So we will go and we will create our custom health check, which is this page here. So we click and copy all this code and go back to the code ready workspace and paste it here. So now we will wait. You don't need to stop Quarkus, it can do hot replacement. And we can go and ask for the health check again. And then there is two of them, because there is the database connections health check that was done by us and our own health check. And we have not restarted the application at all. So right now that we have validated that the Quarkus application is running and is working correctly in a local environment, we will deploy it to OpenShift. So in order to do that, as we did with the JBoss application, we will need to create the OpenShift project first. So in here, I'm going to check to the administration view. You should already have the inventory project here. It will be empty, of course. And if you don't have it, you can go and create the project the same way that we did with the other one. Click create project. And if you find any problem, please let me know. So before we can run in OpenShift, we need to add 2 more extensions. First of all, we are not going to use H2 database, we're going to use Postgres. That's what we need, the JDBC Postgres extensions. And since we are running OpenShift, we will also need the OpenShift extension. So I will copy this command here and I will execute it here. Okay, extensions have been installed. So if I go to the phone now, I will be able to see that I have 2 new dependencies that have been added to the Quarkus pom.xml application. Right now, before executing the deployment in OpenShift, we need to configure the prod environment configuration. So instead of dev, which is activated when the Quarkus column dev Maven goal is executed, that is going to run the application in dev mode. And the properties that it's going to use are the ones that start with this dev. And now we're going to add the production application, which is basically using Postgres database. So if we are going to use Postgres database, I think that we need to deploy is the Postgres database. So we can go and click database here. I am on the developer view and on the inventory user to -inventory project. So I can go ahead and I will click database and I will filter by Postgres. Make sure that you check the ephemeral Postgres because we don't need persistence right now. And we will need to modify this database service name, connection, username, and password to be the same that we have on this properties file here. So I will go ahead and change it. So this service name would be inventory database. The connection username is going to be inventory. And the password is going to be my secret password. And the database name, we are going to change it to inventory. Okay. And then we go ahead and click create. So now we are creating an inventory database. And we will need to deploy our applications in OpenShift. Before we deploy in OpenShift, we need to make sure that we are on the OpenShift project that we want to use. So I'm going to change by executing the command OC project and then the project ID, which is user to inventory. Now I am on the project that I want, and I need to build the application. Okay, so we need to go here and just do a Maven clean package on the inventory application. And we will wait until the Maven build returns a successful flag. Okay, now is building the image. We can see that the build is here, so it's running, so the image is being built, but the application is not fully deployed yet. So I'll go back to the code-ready workspace. If someone is not able to find the problems, please let me know in the chat. I am checking it. Okay, so the Quarkus application have been built and is being deployed. As we said before, this blue color here is going to indicate if the application is up and running or not. So one useful thing to do is to use the labels that are provided by this workshop. So if all this is to create the Postgres database here. So all these labels, we are going to label some OpenShift objects. So if the same way that we did with the JBoss, so we can go and query the OpenShift API through some labels or something that it will return more than one resource. So now we have the inventory and the inventory database. So we will open the application and we can see that it's up and running. That it is running successfully. So we have already checked that the application is up and running. So one thing that we are going to do is we're going to validate the health check that we have added. So we can go here. This command here, oc get route, this is going to return the URL that the application is being exposed to. So I'm going to check the health check now with the full command. And we can see that our health check is already up and running. Okay, so before going forward, the application is running in OpenShift. So we will need, we will go and adjust this proof timeout. The proof timeout is, or OpenShift proofs are checks that the OpenShift is doing in order to see if application is up and running correctly. So we're going to check our readiness. We're going to add a readiness proof to the inventory service by executing this OpenShift command. Okay, so it returns that the proof is updated, and we now go and check the inventory object, and we can see that there is a liveness and a readiness proof that are configured into the inventory. So now, as an exercise that we can do is we can see that the status is dead. Why is dead? Because the application was redeployed. We have changed the deployment config, so the application is being redeployed right now. So we will need to give it a minute to come back up. And now it's back up and running. So this is the status is okay. So what we are going to do is to try to corrupt the service and try to see if this status change. So in order to do that, we are going to go into the pod and kill the process. So we execute an OC remote shell into DC inventory, and we execute the killed one process. And we go back here and we see that the status is now dead. Since the status is dead, OpenShift will restart the pod, because if it is not able to, if the pod is not able to, now it's back okay. If the pod is not able to return as successful when the props are done, then OpenShift is going to go either to not to route traffic into that particular pod or to restart the pod. So at the moment, we have a Quarkus application running in OpenShift. It's running successfully, as you can see here. And we are going to go ahead and create a new application. So we can go to the next section. At the moment, we have the old monolith running in OpenShift and the inventory microservice already running in OpenShift. So what we're going to do is we're going to create a catalog service, and we are going to communicate it with the inventory service. And finally, what we're going to do is we're going to change the UI to, instead of call the monolith service, it is going to call the microservice. So what we are doing here is we're moving functionality from the monolith to a microservice architecture. So in this particular case, the catalog microservice is not going to be served by the monolith application. Is going to be served by the catalog microservice, and this exercise can be done with some other services, not only catalog and inventory, of course. So just to show that not only Quarkus, which is a cloud-native framework, can be used in OpenShift, we can use some frameworks that we are more, or developers we are more used to use, like a Spring framework. And in this case, the catalog service is going to be running, is going to be executed with a Spring Boot. So first of all, we will need to check in the code ready workspace that the catalog service is here. I'm going to close all the tabs that I have opened, and we can see that there are some packages here, but there is no code on it. So before that we check, we are going to go to the POM. So what is the POM doing? The POM is importing these dependencies, which are provided by Red Hat. This is a set of dependencies that we will not need to declare. It is provided by Red Hat, and also the Spring Cloud dependencies, and also some Javax and JSON dependencies and Postgres. Okay, so we need to add some dependencies here. First of all is Apache Tomcat, so we can go and run the application and execute it at Tomcat. Okay, and then we will need to communicate with the catalog database, so we will need Spring JDBC. What else do we need? Oh, sorry. Yeah, Actuator, which is going to Actuator is going to create some proofs for us, and also OpenFind, that is a client that we can use to communicate with the inventory microservice. And we're going to use Histrix as well as a circuit breaker tool. So I'm going ahead and I'm going to add all those three dependencies to the POM. And I am going to check that the application is working. So I'm going to the catalog application and I execute a Maven clean package. Okay. So the build is successful, which is no surprise because we don't have any code. What we're going to do first is we're going to create a repository, product repository, because it's the what we're going to consume. We're going to consume products. And okay, the source class, the source code for this class should be here. We can go ahead and copy it. This is a Spring framework. There is nothing special on it. we will go to the here. We're going to auto-write a JDBC template. We will need a row mapper as well for the product. And we will create some read all and also a find by ID method. All the code that I am pasting is on this workshop, the code here. So all of this is Spring JDBC dependency. There is nothing special. We are used to configure this code or to use and implement this code. So before we continue, we're going to add properties to the application, and we can go ahead and add the database properties that, as well as we did with Quarkus, is an in-memory database for our local testing. Instead of having a separate database, we're going to use H2 in memory. So we have the repository, and the database configured, so we are able to consume it. Now we will need to create the REST service, or well, first we're going to create a Java service. We are going to create a Java service. I'm going to call it catalog service.java. And this catalog service is going to consume the product repository. And it's going to have two methods. So it's pretty straightforward. We have the service annotated as a service, a Spring Framework service. And we have two methods that are directly going to call the product repository. When we have this up and running and configured, we will add an inventory client, which is a client that we are going to use to communicate with the inventory service. And we are going to get some information from that service to add to our product and to return it to the coder. But before we do that, we are going to create the endpoint so we can check that everything is wired together. So catalog endpoint.java, and we can go and get this code and paste it here. So what is happening here? So we have taken an empty application and we have created a product repository that is going to communicate with the product database, and is going to either return all the records that are on that table, or is going to return a record by ID. That is going to be consumed by the catalog service, which we're going to enrich after we test it with an inventory service, and all of this is being exposed, in the catalog endpoint, which is on the services/products endpoint. So before we continue, I'm going to check that I have not done anything wrong. Okay, so the application is up and running. Now I'm going to check if the application is working, because even if the communication with the inventory service is not ready, we can check that the product database and the service and the product and the catalog endpoint is everything working. In order to do that, we will need to execute the Spring Boot run Maven goal, which is going to, similar to the Quarkus dev, is going to execute the application, or is going to run it locally. Okay, So we have the application already started. So I want to check that it is running. So mind that this message Tomcat started on port 8081, so it's not 8080. We go to the Quarkus tools and we can go, should be HTTP localhost 8081/services/products, and everything is okay. I'm receiving back some products from the database. So I have called this endpoint, which is calling the catalog service, which is executing a query into the catalog table, which is what the product repository is doing. So now that the application is running and everything is wired together and connected together, I am going to add the inventory client to the application. So what we will need to do that is to code an inventory client, which is going to be coded into the client package, which is, we're going to call it inventory client.java. And I am going to get the code from the workshop here. Okay, so this client is going to communicate with the inventory service in this endpoint, which we have not added yet, and is going to do a get into the /services inventory/item ID, which is, if you remember, is one of the endpoints that we have created into the inventory service. So if I go to the inventory service and I check here, we will be calling this endpoint, this particular endpoint. Okay. So before we start it, we are going to configure the endpoint. We should be here. Okay. We're going also to enable histories, and as it is set here, we'll need to auto-wire the inventory client into the catalog service, so we can use it in order to enrich the product object. So it is, what is happening? Okay, let's import it. Okay, so we have the inventory client we have injected it into the catalog service. So what we need to do is to call it or to execute this inventory client and get, in this case, the quantity. So we will need all this code here. So this code, we are going to add it here. What is going to, or what is doing basically, is calling the inventory client and get the quantity and set it into the product. So the quantity is something that is going to be returned by the inventory service, and we are going to enrich our product model to add that quantity. So when the UI calls the catalog service, it will not only receive the catalog database information, but it will also receive some of the inventory database information. I'm going to go ahead and add all the code for the read all method, which is exactly the same code. It's going to call the inventory client and it's going to go to get the quantity and set it to the product that we are creating. One important thing before we go forward is that since we have history, we can create a fallback here. What is the meaning of a fallback? So the meaning of this fallback that we're going to create in this microservice architecture, a problem that may happen is that you will need, or sometimes the service is restarted, sometimes the service is slower because it is under a high load. So what we are going to do is, in the case of a failure, instead of return a failure, we are going to return a fallback. So we are, instead of returning the error, we are going to return a quantity -1 to the caller. So we go here and we paste this fallback here. This is enabled because we have enabled it before into the history.enable flag. So that is why we can do this. And finally, we will need to specify it here. We will need to specify a fallback factory, which is going to be inventory client dot inventory client fallback factory dot class. Okay, so this is the fallback factory that we are going to to use here. And I am going to check if everything is running okay. Okay, so we can go back here. So we are at the section 9. So having fallbacks is, as it is stated here, is good, but sometimes we also have slow running services. So we are going to add this heuristics property. So we are going to set a timeout for the inventory service. We don't want to have a long running call. We want to fail and go on. So before we deploy this to OpenShift, we will need to check that everything is running. So I'm going to compile the application again. Okay, it's working. And now I need to do Spring Boot run. And so if everything was correct, if I execute the same, you can see here that the quantity is 0. So if the quantity has a value, it means that the inventory service has been called. So before, when we didn't have the communication with the inventory service, quantity was 0. Right now we have a quantity that is being returned by the inventory service. And in the case that the service fails or it is too slow to answer, then we will return a quantity of -1. So the code for the catalog service application is done. And before we deploy it to OpenShift, we will need to do the same as we did with the inventory, which is to create a database. So we go back to the catalog, select database, and click Postgres, and instantiate template. So in a similar way that what we did with the inventory, we are going to call it catalog database. Connection username is going to be catalog, connection password, secret password, and database name catalog. Okay, and we go ahead and click create. One thing that we need to do is we only have application -default properties. We don't want that because that would mean that we are running with local configuration. So we are going to create an application -OpenShift dot properties. And since when we run the application, we're going to run it with the OpenShift Spring profile. So this is what is going to be loaded. I go ahead and I will copy the content, which is on the workshop in section 11. And okay, database is already up and running. So right now, what we need to do is to deploy the application to OpenShift. So before we do that, we will need to build and deploy the application. Where here, I'm going to stop it. And I'm going to copy that Maven command. Okay, success. So in the target, I have the catalog 100 snapshot.jar. That is what we want to run in OpenShift. So I'm going to change the project to user to catalog. Oh, OC project. And now we are using the project. So first of all, we will need to create a build configuration to build the application. So we do the command OC new build, and we will need to specify the image that we are building from, which is registry.access.redhat.com/uba8/openjdk11 is of type binary, which means that we are going to specify the input. The name is catalog Spring Boot because that's the name we want, and we also have a label which is catalog Spring Boot. Okay, success. So if I do an OC get build config, I can see that there is a build configuration here, but we need to execute this build configuration. So we need to start the build, catalog Spring Boot, and we need also to specify the from file because it's a binary build, and it's going to be target catalog service 100. So what have we done here? We have specified this JDK version and this jar file. So basically, we are going to create an image, which is going from this base image, OpenJDK11, and we are going to add the catalog service jar file and run it as and create a new image with it. Okay, so the build is created. We can go here and go to builds, and we can see that it's running. So when it is finished, we will have a new image of the catalog service created in OpenShift that we will be able to deploy. Okay, it's completed. So we have started the build, and now we want to deploy the application. Mine this sprite.profiles.active is what is going to allow us to load this application OpenShift.properties. So that is important. So we will need to deploy the application. Go ahead and create it. So the resource is now created, and if we go back to the topology view, we will see that it is being started. Now, one thing that we need to add is a route to the application. So this application, if we go to the cover the workspace and do an OC get roused, it is not exposed. So that means that it is not possible to execute it from outside the cluster. So we will need to expose it. In order to do that, we need to execute this command here, which is oc expose. And also it's going to add some proofs to the catalog Spring Boot deployment config, something similar as we have done with the Quarkus application. So I'm going to create everything. So if I go and I execute an OC get route, now I have an endpoint. And I can go ahead and check this endpoint, and it's running. So this route is calling the catalog service that we have written, and the catalog service is calling the inventory. And as we can see here is the quantity of objects that are on the inventory database, not on the catalog database. If you have a problem or you are not able to reach this point, please let me know on the chat. And as a last part of the workshop, what we're going to do is change the endpoint of the UI. So the UI of the moment, if we go back to the cold store application, is consuming the monolith application. So what we're going to do is go ahead and change it to the catalog microservice, because we have already created it and we have tested it's running in OpenShift, and this particular object can be consumed by the frontend. Don't worry, the only thing that we are going to change in the UI is going to be the URL that we're using. So first of all, we will need to go back to the inventory. We will need to enable course. So we will go to the inventory. Oh, sorry. We go to the inventory service and application.properties. So we want to enable course for production, and we need to rebuild and to redeploy the application. So we need to change the project to the inventory, because we don't want it to be deployed in the catalog namespace. And I'm going to do clean package, and I'm going also to skip the tests. And this is going to deploy the inventory service in OpenShift. So we can go to the inventory, we can check the inventory. So we have both of them. Okay, while the inventory is being deployed, we can add cores to the catalog. So I'm going to the catalog endpoint, which is here. And we will need to add the cross origin annotation, which is this one. So when the inventory is redeployed, we can go ahead and redeploy the catalog application. In order to redeploy the catalog application, we will need to reveal the jar file and to do a new binary build, because it's a new image. We have changed the code. Okay, inventory is deployed. Inventory is okay. Okay, so I'm going to change the project to catalog. I'm going to move to the catalog folder, and now I'm going to execute the catalog build, because I have already changed the code. And if we go here, is all this command is building the application, the Spring Boot application, and also starting the new build. That is exactly what we need. So I go ahead and paste remaining command. We will give it a minute until the new application is running. Okay, now it's doing the build, it's building the new image. A new image for the catalog service. Okay, now the image has been filled, and if we go to the catalog project, it seems to be already up and running. Okay, so now we will need to go back to the monolith and change the JavaScript that executes the call to the catalog service. So if we check the workshop documentation, it is under source main web app / app services. And then we will need to find this face URL parameter and change it. So I'm going to the monolith, app services, and I'll need to go to catalog.js, and I need to find the base URL, which is, where is it? It's here, and base URL equals source product. Yeah, we're going to we could go ahead and add it here, or we can go and, yeah, I think we are okay to delete this. Okay, so before we continue, as we have done with other projects, we need to rebuild the application. So I'm going back to the monolith, and I'm going to build the pack. I did it run package. It is going to work because I have changed a JavaScript. So application is working. So I will go ahead and build the new application. So I'm building it. So this command that I just executed is doing a clean package, the same as we did before. It's creating a WAR file. And instead of changing the project each time we execute an OpenShift command, it is specifying the project here, which is coolstore, which is the one that we have used before. And also specifying the WAR file that we want to use. So, okay, the WAR file has been built and it is been uploaded as a binary input. Okay, so when the image is filled, the deployment will be updated because there is a trigger configuration that when a new image is being created, that image is redeployed into the deployment that we have. So we don't have to be worried about when to deploy the image because it's already been deployed. So you can see that the application is not ready because it is being redeployed. The moment that is ready, we will go ahead and check it. And if it works, then it will mean that we have changed the catalog service of our application, of our cool store application, from the monolith that we had running in WebLogic to the microservice architecture that we have running here. So as you can see, the quantities are being returned, the prices are being returned, and everything is working smoothly. So before we wrap up, I would like to summarize what we have done. We have taken an application that was running on WebLogic. We have removed all the WebLogic specific code, migrated to a JBoss application server that was running in OpenShift. That is the same application that is a monolith, but we don't have the agility or the speed that we have with microservices. So we are starting coding a part of the application in microservice frameworks like Quarkus or Spring Boot. That part of the application was the catalog service. And when the catalog service was already built and tested, we can go ahead and change the user interface to consume the microservice instead of the legacy monolith microservice. So that's all on the point of view of the workshop. Thank you very much.
Marcus, thank you very much for that. Let me actually just for one moment just take back, if you just stop that screen share, I'll just take that back and I'll just screen share myself a moment. There we go, just bear with me one more moment and we'll go to here. There we go. Okay, so just want to, I don't want to take it in, you know, it's a long time already to take, and I don't even think you've had any toilet breaks or anything. So all I want to do, I want to just wrap up on this, on our website, just to point out to you, I'll just turn my video on as well, just so you can see me talking. Just want to point out to you to go to our events page, so at crossvale.com. If I just go down there myself to the events page, I know you're sick already of looking at screens, it's just another screen to look at, but if I'm just going to bring you to it, you can see the roadshow that we've kicked off today on migrating workloads here. And then if you just scroll down a little bit, you can see the other three that are already available. And you can register immediately on here. This will, just so you're aware, this will take you straight away to the Red Hat events website, because we work in partnership with Red Hat on this. So we're doing this together. So don't be surprised. When you click the register, it will immediately take you over. As you can see in the bottom URL, it'll take you to eventsredhat.com, and you can sign up there, and then we collect that and send out all the relevant information to you. So do be expecting that. Also from me, you'll get an email shortly just saying thank you obviously for attending, but also it'll be a link to the actual on-demand itself. So if I just go down to some of the on-demands, we've just done a workshop on Ansible, for example, so you can have a look through there. And as well as workshops, we've also did, just earlier to that, we did a webinar on Ansible. And, you know, again, they're quite different to each other. They're more, rather than instruction-led workshops, they're more discussing around what is this product, what will it actually do for you, and we go through examples of things like that. But we also have a RHEL webinar, as I mentioned earlier, around, you know, if you're on 6 and you're looking to maybe come to 8, what are the pitfalls, what are the things you've got to watch out for, and how can we help you, you know, navigate around those pitfalls. So there's a piece we do on there. And also when it comes to DR, we've got a nice one there around the whole OpenShift DR. Most people are looking to that when they're at the production level for OpenShift. They're looking at what their HA and DR setup really is in terms of failover, etc. So we've got a very nice on-demand webinar where we actually take you through a real-life disaster recovery. So we actually fail a whole cluster and then we rebuild it up again, so that you can avail of that if you like as well. And then good old-fashioned OpenShift webinar going through a little bit of a 101 around 4.x, learning about all the things you don't normally talk about all the things that are underneath the covers, and we get inside there just for 45 minutes. So again, please go on there. And if there's anything else you'd like to know or anything you'd like to learn, just ping out to us. You know, you have our addresses down there, but follow us on the LinkedIn, etc. Please reach out to me on LinkedIn as well, and tell me things you'd like to know that are going on. But I just draw your attention to a lot of our blog posts that are going on, and the guys that you're hearing from today, Marcos and Carlos, they contribute to those blog posts. So I do ask you to go there as well. Okay, so I'll leave it there. Once again, thank you to Marcos for, I think even without a coffee break there, going through that whole workshop. So thanks a lot, Marcos, for doing that and taking the time to do that. Okay, so we'll close this down and we'll make the recording available, and we'll be in touch soon. And I look forward to seeing all of you and your colleagues at the next workshop. So